So back to our track checkout, if you recall from before, that silly scenario about the e-commerce. And rather than passing my call back in, what if we were to modify that API such that it returned back an event listener to us? As you see on line 11, I receive a listener back from the track checkout function, and then on line 13, I listen to the completion event. And when it finishes, I move on. And I listen to the error event, and when it finishes, I move on. Can you see how that is uninverted the inversion of control, or rather just simply retained control? Because now, rather than passing my call back into that utility, giving them the keys to the kingdom by which they can do whatever they want, and I can't trust that they won't do what I don't expect, I've retained control. I've simply said, no, you give me an event listener, I'll figure out what to do. I'll listen for that event. And we could wire it such that we listen for the event and then unsubscribe to the event the first time it happens, for example. Like, we are in complete control of that paradigm. So we've normalized, we've brought more sanity back to this process rather than passing the call back in. That's an important understanding of promises, is that they uninvert the inversion of control problem. That's a big deal. That's not a small point. That's one of the most important points. Promises were designed to uninvert that inversion of control, or rather to retain that control, so that all of those trust issues that we were talking about before have an ordered and patterned way of being solved. Now, we don't actually listen this way. This isn't how most APIs are designed, although it's an established pattern that we can at least understand, but it's a metaphor for thinking about a promise. A promise is like an event listener. But rather than there being a completion event, we call that event the then event. And that's where we start to talk about the API of a promise. So in that track checkout utility, rather than receiving a callback as a parameter, we can simply create a promise. As you see on line 2, I'm constructing a promise instance. The constructor for the promise receives two methods, the resolve and the reject. It's pretty clear what those do by the way I've named them. You call resolve if you want to resolve the promise, if you want to fulfill it completely or correctly, and you call reject if you need to reject the promise. Back to my future cheeseburger, those are the only two options. Either I'm eventually going to get my cheeseburger, or the lady's going to call me back up to the counter and say, this is a tragedy, but we are completely out of cheeseburgers. I'm going to have to give you your money back. Those are the only two options, right? Either I get my cheeseburger or I get my money back. So we can either fulfill a promise, calling resolve, or we can reject it. Those are the only two outcomes that a promise can have. So whatever that magic is, I'm eliding that information because that isn't the important part, but whatever that logic is inside of track checkout, it either needs to call resolve or reject. Now, you notice that we're returning that promise instance. So when we return that promise instance, we're going to use it in our code. Just like I'm doing here on line 11, I receive a promise back, and then notice how line 13, instead of saying .on completion, I'm saying .then. I'm registering for the then event. The then event is going to be called when either resolve or reject is fired against that promise. It will fire the then event, if you will, metaphorically, and one of those two functions passed into it's going to get called. Finish will be called if the promise was fulfilled successfully, error if it was rejected. So we have actually a nice, clean mechanism for being notified that it was either a success or that it was a failure. It's an incredibly important step forward for uninversion of inversion of control. Inversion of control is sometimes used in an intentional way. Framework design authors sometimes will use, in fact, inversion of control is one of the key characteristics that has classically been used to define something as a framework, is when it inverts control. When you pass in stuff and it calls it for you instead of you calling things. I don't know how many of you are familiar with some of those more classical thinkings about software design, but that's one of the characteristics that divides between a library and a framework, is that inversion of control. So some people will tell you that inversion of control is an intentional design feature, and I would tell you, as far as asynchronicity is concerned, it's a terrible idea. Inversion of control is the path to the dark side here. It is the path by which we completely lose all reasonability in our program. So we are trying intentionally, actively, on purpose, to uninvert that paradigm, to bring it back into our control. That's what promises are doing for us. See, this isn't actually about an API at all. This isn't about, lack of indentation. In fact, if you pay close attention, you notice there's still a ton of callbacks here. In fact, there's more callbacks here than there were before. Wait a minute. Hold up. I thought promises were all about solving callback hell, getting rid of callbacks. How on earth are they fixing anything if there's still callbacks involved? Really important question. If there's still callbacks involved, how does this promise system offer any solutions to us? You might ask, and rightly so, well, wait, if I pass my callback into that promise, can't the promise just call my callback a bunch of times? How can I trust the promise to do what it's supposed to do? That's the most important question that can be asked at this point. Because you need to understand that promises were designed to instill trust into this transaction. The fundamental design principle that they're only resolved once. They can only be resolved as a success or an error. The messages that get passed to a promise are always kept. It becomes immutable. Exceptions are always caught and turned into errors that are always observable. There's nothing swallowed. If you choose not to observe because you're lazy or you make a mistake, then it might look like it was swallowed, but it definitely was not swallowed in the sense that you had no opportunity to observe it. This is a huge deal. This is a whole bunch of sanity brought back to a process that has fundamentally been rather hard to understand and rather hard to maintain for the entirety of JavaScript's history. So herein we do start to see some of the benefits of the API. These are things above and beyond this notion of time-independent state. I said that was important. That's our foundation. Built upon that, we have all of this trust added to it, and that is primarily the mechanism in the API that we've been given is designed to organize our callbacks in that certain way. In fact, you might think of it, a third way of thinking about what a promise is that it's a callback manager. It's a pattern for managing our callbacks in a trustable fashion. That's a big deal. That's why promises matter. It's not really so much about whether you like the shiny API or not. It's not really about whether you want to get rid of nesting or indentation. There's a promise hell, and it's easy to get into. There's no silver bullet. But there's a really important thing that they've been designed to do, that is to instill trust back into our systems. Even more than just trust in this way, now that my value is immutable, I mark that one on purpose because now that my value is immutable, from the outside it cannot be changed. That means I can send that container to any port of my system or even outside of my system to other third parties. And I can say, here is my value, and I do not have to worry that they're going to change that value out from underneath me. You remember we talked about immutability in the other workshop and how important that is? That's one of these fundamental in fact, one of the most important things is that they're externally immutable. There's no action at a distance concern here. If you don't know that phrase, action at a distance, that's one of the evils of software architecture. When you design a system where somebody else far away can do something that affects you without you knowing it. It's a bad idea. Just as a little side note here. There are discussions happening around promises that in a future version of JavaScript we may get this notion of a cancelable promise. I'm not going to go into all the politics and all the craziness that's around cancelable promises. Just briefly to state to you, it's kind of a tail wagging the dog as far as I see it. They have this other sort of thing that they want to control, and that thing that they want to control only exposes promises, and so, let's make promises cancelable so that we can control that thing instead of making that thing controllable. It's crazy to me. But you know what's bad about cancelable promises? Action at a distance. I have a promise that's not yet resolved. I pass it to somebody else and they can cancel it out from underneath me? What? That's nonsense. That erodes the entire foundation upon which these things are built. So if you see me ranting about cancelable promises, this is why. I take it seriously, because this is an important thing. We shouldn't throw it away just because we're drunk on this idea of pretty APIs.